My name is Arvind. On behalf of Crack Verbal, I'm really very happy to conduct this session for all of you to help you ace a topic that is typically considered difficult by a lot of students. So we have aptly named this session as how to get permutations and combinations right. And I think over the next hour or 75 minutes, we will be discussing some useful strategies for you guys to go about increasing your accuracy rate on a topic like permutations and combinations. Typically, you can expect around 2 or 3 questions from this topic on the GMAT Quant section, right, on any given day. And you can expect questions from any difficulty level, right, starting right from a sub 600 level, right up to a 700 level. Um, so we'll discuss questions of different difficulty levels of different models over the course of the next 60 to 70 minutes, and we'll also see how we can help you from our end in terms of imbuing you with a lot of confidence to solving permutations and combinations questions much better, and thereby increasing your accuracy rate. All right. Um, so my name is Arvind. As I told you, I work for Crack Verbal, and I'm a mechanical engineer by qualification. I graduated out of a college called UVC in Bangalore. I did dabble my hands at mechanical engineering for almost like 9 years, but in parallel, I also had this interest towards teaching. I started off primarily as a CAT coach for about 10, 12 years, but I've been teaching GMAT GRE for the last 10 years or so. I've taken the GRE myself when long back when it was a question adaptive test similar to the GMAT, and I scored a perfect score in GRE Quant. I've also taken the CAT more than thrice, and I've got a 96 percentile, more than once without putting in a lot of preparation, as is the case sometimes with us faculty people. Yeah, I'm also a very religious cricket follower and interested in tennis. A very big fan of Nadal. Also follow Formula One racing. So that's about me. I hope that was a quick peek into who is talking to you over the next 1 hour. Before we start off, a few basic ground rules. During the session, use the chat window for any queries that you may have, any general queries that you may have. Um, you can ask me questions when I stop explaining about a strategy or a question. But if I'm explaining something, if I'm giving an explanation or strategy, and if a question suddenly crops up in your brain, just hold on to it, write it down somewhere in a book or a piece of paper, and you can go ahead and ask that question immediately after I stop explaining, right? So that we don't have to do too much of context switching, right? I'm definitely not against asking questions during the interim also, right? I believe that any question that can extend the discussion is always a good question. But if you have a question that you think you can hold on to till the end of the session, please do so. Because after the session, I have a good 10 to 15 minutes open for questions, any question that you may have, either related to the topic that we discussed till then, or maybe even generic questions, right? So as far as possible during the session, try your best to keep your questions restricted to the context that we are discussing. After the session, I'm open for any questions, right? Okay. Um, so what is the agenda for today's session? I've kept the agenda very simple without complicating it, because the 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 topic that we are discussing is anyways perceived to be complicated by a lot of test takers. So I thought, at least from my point of view, from my end, let me keep uh, the agenda plain and simple. So we'll be starting off by discussing the common pitfalls, the common troubles that students experience in PNC questions. Then we'll understand how to use the fundamental principle of counting, right, as a basis to solving permutations and combinations questions. We'll slowly, transition into solving permutations questions from there on, right, and then on to combinations questions. The last stage Rather, the last two stages are where I will cover permutations and combinations questions with restrictions, with constraints, positive, negative, both. Sixth, I have some application type questions where you'll have questions where you have to apply PNC concepts, but they will not appear like they are PNC questions explicitly, right? There may be some other concept involved in solving that question as well. Okay, so this is what I've set as the agenda for today's session. So without wasting any more time, right? I'd like to move on to the first segment, the common pitfalls or the common troubles that students experience in PNC questions. And this is where, like I always do in my sessions, like I always do in all my PNC sessions, I want I want you people to tell me what do you think are the common problems that you face when you solve questions on PNC, right? Go ahead and type your answers in the chat box. I would like to know what are the problems you usually face when it comes to PNC questions. Yes, go ahead. Type your answers in the chat window. And yeah, I do have the chat window open, so I'm going to have a look at the question at your answers and probably see if it matches with certain things that I've listed out in the upcoming slide. So please go ahead. What do you think are the common problems that you people face when you solve PNC questions? Difference between choosing and forming, right? Okay. What else? Okay, that's one. And I'm not surprised. I'm not surprised that that is the first answer that is coming up, right? Um, Finding the overall denominator or total sample in a particular scenario. Rahul, I'm having a feeling that you're probably talking more about probability questions, but yes, I would accept that as an answer also because I always feel that probability is like a logical extension of permutations combinations. Formulate the equations based on the problem, which would boil down to your ability or inability to comprehend the language, probably convert the language to math, probably yes. Okay, that's one more. What else? A lot of you have not given one important answer that I was expecting that some of you would. Anything else? Anything else, people? Deciding whether to choose all at once or choose one after the other. That's a good point. That's a good point. That again, I think boils down to the situation where you're unable to decide should I form cases here or should I directly apply the formula or should I directly apply the fundamental principle of counting? Yeah, good points. Good points. So I have kind of made a list based on my experience of having taught PNC for the last 14 years, which I've thoroughly enjoyed. So PNC is one topic that I really enjoy teaching as well because it kind of brings out the best in me, and I also feel that I'm able to inspire students to think of different methods of solving. Right? Difference between PNC, complex counting, double counting, and combinations. All right. So that brings us to some of the common difficulties. Right? There is a reason why I've put the word common here. Now, I feel some of these are the most commonly faced challenges by students when you solve PNC problems. And of course, number one is no doubt no prizes for guessing. A lot of you will come back and say, I'm not able to understand when to apply the permutations concept and when to apply the combinations concept. Given, that's a given. But a lot of times, a lot of people don't know shortcuts to calculations, right? I've seen people solving for like values like 11C3, right? So if I ask people to solve 11C3, they would end up doing this 11 factorial by 11 minus 3 factorial, right, into 3 factorial, and then going on to simplify. That's a lot of time, right? You don't have that luxury on the GMAT quant section. You need to know certain standard shortcuts to calculating faster, which can help you save some time on every question on PNC. Third, obviously, I've not listed this down in like the increasing order of challenges. I've just randomly put them there. Comprehending the language to break it down, right? Sometimes permutations, combinations questions, being word problems can be really complicated in terms of language. They can be very lengthy, right? And that's where I agree with who said this. I think Nishchal, right? Nishchal said it's sometimes hard to convert the situation given into a mathematical equivalent, right? Visualization. This is something that I wanted one of you to say, right? Visualization of the scenario described in the question, right, is a very important, should be a very important part and parcel of your problem solving process for PNC, right? And if you're not visualizing the scenario enough, you will you will most often end up getting the wrong answer, right? People are not able to visualize, right? They think formulas can get them across the line. Whereas if you don't visualize the scenario, you don't know what formula to apply, correct? And then you end up using the wrong formula most of the times, and that'll end up causing more trouble, right, than good. Fifth one, this is what I have seen in my experience as a teacher, that people don't use logic. There are a lot of questions where using pure logic and a little bit of common sense can go a long way than using math alone, than depending on formulas alone, right? It is when you depend on formulas, you'll come back and tell me, I'm not able to understand whether it is P or C, right? You can't be too dependent on math. You'll have to use a lot of logic and your reasoning skills. And the last one is what I think Riddhi said, not knowing when to develop cases and when not to, right? Most often students end up, doing it the other way around. When they have to develop cases, they don't. And when they shouldn't develop cases, they end up, getting into numerous cases and getting into trouble, right? Embroiled in that situation, which they're not able to get out of, right? So these are some of the common problems that I have seen students facing, right? And I'm sure a lot of you will agree with me on a lot of these points. So, therefore, the whole idea of this session is to address how you can get over some of these common problems and look at PNC questions from a fresh perspective, right? From learn simple techniques of solving permutations and combinations questions without feeling that they are a hard nut to crack, right? And for you to be able to do that, um, you'll have to be very good at something called the fundamental principles of counting. I remember having read somewhere about PNC on some website or in some book where the author says, if you come to think of it, permutations and combinations is finally about counting. And he goes on to say, although it's about counting, we end up making so much of a fuss about it, right? Because we get embroiled in formulas and mathematical techniques that we forget that PNC is, after all, about counting. And I'm sure if you guys can count, right, I'm sure you can definitely do well on permutations and combinations. So start off with that mindset, right? And tell yourself that the foundation of permutations and combinations is based on counting, right? So, what are the fundamental principles of counting? There are two principles. They're also called counting methods, right? The first one is called the addition principle, which says if task A can be done in m different ways, task B can be done in n different ways. You must have already seen this a lot of times. The number of ways to do task A or task B is m plus n. So very often you end up reading this. You end up hearing a lot of people saying, okay, if you see a or, you add the values. My thought process is, I want you guys to think about when an or will be used. When do you think you will come across a situation where you have to use or, right? And that's why I've said here, you come across or, right, when events are mutually exclusive, right? If you know that two tasks cannot be done in parallel or cannot be done simultaneously, you either do one or you do the other, right? In all such situations, you end up using or, right? And or means addition. This is a better way of remembering the addition principle, right? Very often, this word or is given as a clue in PMC questions. But unfortunately, students, right, in their exuberance to get to the answer quickly, end up missing the or. Or is a clear-cut clue for you to think of developing cases, which means you have two cases or three cases, and you go about adding finally, right? The second principle is called the multiplication principle. And remember, multiplication is nothing but repetitive addition. So I can go to the extent of saying that the multiplication principle is just an extension of the addition principle. So what does the multiplication principle say? Task A can be done in m different ways. Same statements, task B can be done in n different ways. Then the number of ways to do task A and B, right, is m into n. Again, very often you would have heard that and means multiplication. Yes, that's right. But again, when do you use and? In what kind of situations would you use and? You would use and when events are not exclusive. Very straightforward, simple answer. But think about it. You would use and when you do certain things simultaneously, right? Or together. Where you're saying, I'm going to do this as well as this, right? So that comes in the visualization part. When you visualize a PMC question, you understand, will I do this and this? Will I do both together? Or will I only be able to do one of them at a time? Right? That will end up telling you whether you add values or you multiply values. Right? So after I explain the fundamental principle of counting, I have this habit of asking students a very simple question, right? And I'll just shift to the whiteboard. Okay, let's say there is a city a city B, and a city C, right? City A is connected to B. Let us say using five routes, five different routes, of course, not identical. City B is connected to city C, let's say using four routes. And a lot of you, by this time, you're expecting a question to come up. Right. Here comes the question. So I would ask you, what is the number of ways of traveling between any two of the given cities? Right? No options, because this is a fairly straightforward question. Right? What do you think is the answer for this? What is the number of ways of traveling between any two of the given cities? Go ahead and tell me, what do you think is the answer for this question? There are three cities. A to B can be done in five different routes. B to C can be traveled in four different routes. Number of ways of traveling between any two of the given cities. Yes, people, go ahead. No options though. Yes, people, don't feel shy. It's okay to get answers wrong sometimes. Okay, I see a 29. 29 is an interesting number. Probably did not expect that number. Any other answers? 20. Okay. Just want to see how many more 20s come up, because that's 20 is a common answer. 20 is a very common answer um, for those of you who do not visualize, right? And who do not pay attention to details. I said traveling between any two of the given cities, right? A lot of you who said 20 ended up assuming that I asked you to travel between A and C. Yes, traveling between A and C is only one way of traveling between any two of the given cities. So that's where the visualization part comes in. When you say any two, you can travel from A to B, or, right, you can travel from A to C, which is obviously through B, or you can travel from B to C, right? So A to B can be done in five ways, or you can't do all of them at the same time, right? That's obvious. You can't say I will travel from A to B, A to C, B to C all at the same time. These are mutually exclusive events, right? So A to C would obviously be 5 into 4. That's the answer that a lot of you thought would be the right answer. But that's only a part of the answer, right? So 5 plus 5 into 4 plus another 4. So this is a problem that kind of symbolizes how you can use addition and multiplication in the same problem. And going forward, when we come to permutations questions, you'll see quite a few questions where you have to use both, right? You'll have to have this basic understanding of when to use which one, right? So that's 5 plus 20 plus 4, that is 29. 29 is the correct answer. Well done. Quite a few of you got it, right? And quite a few of you had to retract your answer and correct yourselves. But that's the way we learn. All right. So, how do we go about using the fundamental principles of counting? Can we actually use them in solving PNC questions? I would say, why not? Right? I've picked a couple of PNC questions, combinations questions. GMAT has this habit of calling them combinations questions because combinations is like the foundation. Most of the questions that I've picked today are official questions, right? Questions that were either found in the OG or the Quant review or maybe the GMAT paper tests, right? So why don't we start with question number one? I will probably have a 2-minute timer. Go ahead, solve this question. Relatively simpler question to start with, right? Um, just to set the juices flowing, maybe a warm-up question if you think of it that way. Okay, that's about 45 seconds. If you have an answer, just hold on to it, right? So that the others who are solving can continue to solve. Hold on to it and post your answer only when I ask you to post it in the chat box. Okay, that's a minute and a half almost. Okay, that's almost 2 minutes. AJ, I think the video will definitely be available for viewing later. Don't worry. Okay. So how do we go about solving this? So what does the what do these two roots tell you? You could probably name the points if you want to call them maybe C, D, E, and F, and this you could call them G, H, J, and K. Yes. So how many ways are there to start from A? You could go from A to C, or you could go from A to G, right? Which means there are two cases. You can't go in you can't take both the routes. You take either this route or this route, and that's when you understand that you are dealing with mutually exclusive tasks here. So what do we do after this? Because there's a or, and because we understand that the diagrams are very identical, we take one case, right? We take probably this case and see how many routes are there for us to get from A to B via this route. And then because there is one more that is exactly identical, understand that x plus x is 2x. So if you have two identical components, you just multiply them by 2, right? So this way to reach C, there is one way. And after reaching C, from C to D, there are three ways. From D to E, there are three ways. From E to F, there are three ways. So 27 ways of getting from A to B through C. So how many ways will be there to get from A to B through G? It would be the same. 1 into 3 into 3. So that would be 27 plus a 27, which would be a 54. How many of you mark 54 here? Not a lot of you. Billy probably is the only one. So please understand that you can't make a lot of careless calculation errors in questions like these. And you also need to be aware that there will be certain numbers like 432. 432 is like an impossible number here, right? Because it's way too big, right? So you also need to have this ability to filter out options like option E, right? Option E is definitely not the answer. Similarly, option A is also not going to be the answer because it's way too small. There are a lot of possible ways here. The moment you understand the first route can be done in how many ways? 27 ways. Option A and option B can be eliminated. So elimination should be a very important part of your strategy for permutations and combinations questions. And you need to learn how to eliminate at different stages. Right? Any questions here? Any doubts? If any of you have a doubt, you can post them in the chat box. I'll probably take a minute to answer any questions you may have before we move on to the next question. Okay, all right. That's great. Let's move on to question number 2. So I hope this question has given you an insight into how using the addition and multiplication principles can help you solve the question much faster, right? This is probably a 600 level question or maybe a sub 600 level question. A question you might end up getting in maybe in the first five, one among the first five questions, right? Let's see what will be the next question now. Question number 2. So here again, let me start a 2-minute timer for you. You can go ahead and solve this question and let me know how you solved it by way of your answer. Hold on to your answers by the time you solve them. If it is not 2 minutes, just hold on to them. All right, that's 1 minute. All right, that's almost 2 minutes, people. You have another 5 seconds. Okay, time up. You can now post your answers. A lot of you say D, 5040. Some of you say C for Charlie, 10P4. All right. So Daksh will come to the concept of NPR in a bit. But the point here that I'm trying to make is you can solve this question in a very easy way if you know how to use the fundamental principle of counting. Um, don't get fooled by the fact that you know the word choosing is there. A lot of people depend on keywords, right? They're told, if you look at a word like choose or select or group, you're supposed to look at this as a combinations question, right? And GMAT kind of uses that as a trap to use a word like choosing during in the initial half of the question to give you an impression that it's probably a question on combinations. But remember, the question goes on to say that she will list the books in the order, right? In the order in which they are chosen. So the order is important here. And from this, you understand that there can be different orders, right? So it's if any of you are like formula oriented, you would get the answer wrong if you say 10C4, right? On the other hand, if you're like, I don't want to use formula, I just want to use the fundamental principle of counting, you will find this a mighty easy problem to solve because the first book can be, or the first block can be filled in 10 ways. You can fill this with any one of the 10 books, right? The second block can be filled in 9 ways. So this is more like that problem where you form numbers, and you know that when you're forming numbers, interchanging the order of the digits will give you a different number, right? And this can be filled in 8 ways, and this can be filled in 7 ways. So you might come back and ask me, Arvind, we have also solved questions where numbers have repeated digits. Clearly, that doesn't apply here because what you're arranging here is a set of books. And once you put a book here, let's say you put book one here, you can't repeat the same book here, right? So this is like solving a question on numbers where repetition is not allowed. So 10 into 9 into 8 into 7, you understand that this has to be a multiple of 7 because there is 7 here. So option A goes out of the window because it's not a multiple of 7. B goes out of the window. C goes out of the window. And you know that this is 90, right? 90 into 56. Now we know 90 into 50 is approximately about 4,500. Therefore, you can eliminate option E because you don't know this product. You know that this product will not be as large as this one. One tip that I would like to give you on permutations combinations questions, especially the problem solving ones, don't always try to get to the final answer, right? It is not necessary. It's not a mandate that you have to calculate the final answer, right? Use smart ways of estimating and marking the answer. Remember, there's a huge difference between solving for an answer and getting to the answer, right? And getting to the answer is what you have to do. So I hope this has given you an idea of how you can go about using the fundamental principles of counting, right, to solve permutations combinations questions without even having to use the formula, right? So the point I'm trying to drive home is that even if formulas fail, you have a method on which you can fall back on, right? But does that mean that you should not use the formulas? I'm not saying that, right? Because in the next section, which is where I'm going to go now, we are going to look at strategies for permutation questions. How do we solve permutations questions? So, what are permutations? What do permutations signify? What is the meaning of permutations? Literal meaning. And by the way, GMAT doesn't have a separate category called permutations. Whether it's a problem on permutations or combinations, GMAT just calls it combinations. But for our understanding, what are permutations? What do we do in permutations? We arrange, right? So when it comes to permutations questions, you need to understand that order is important. Let me shift to the whiteboard here, right? So permutations are nothing but arrangements. A very technical way of understanding it, right? If you ask me, is there an easy way of understanding it? Yes, why not? Sequences, right? Or words, or seating, right? Or a hierarchy. When you think of any of these keywords, what comes to mind? You know that order is important because, let's say, for example, in a sequence, a 1 2 3 is different from a 1 3 2, and a 1 3 2 is different from a 2 3 1. You look at words, you have a word like ATE can become a different word if you turn it to ETA. And permutations and combinations is all about finding those different arrangements. If something is not distinct, you will obviously not count it in, right? Even in seating, right? John sitting to the left of Andy is different from John sitting to the right of Andy, right? Hierarchy. Let's say there are two. Let's say there are five people: A, B, C, D, E. A becoming the president and B becoming the vice president is completely different from turning it around, right? A becoming the vice president and B becoming the president. So when you come across these words, you know that you're dealing with permutations because order is important. So how do you go about dealing with permutations? Of course, we have a formula. We have NPR. But when do you use NPR and when do you not use NPR is important, right? So I classify permutations questions into like three or four categories, out of which primarily one of the categories is permutations with people. So these are basically seating arrangements. Then you have permutations with words and alphabets, of course. And the third one is permutations with numbers and digits. If you ask me, I would prefer using the NPR formula for permutations with people and permutations with words and letters. Whereas if I'm dealing with permutations with numbers and digits, I would probably prefer using the counting methods, the fundamental principle of counting. And there's a reason for this. First of all, um, shift, moving back to the whiteboard, can any of you define NPR for me? What is NPR defined as? NPR is defined as n factorial by n minus r factorial, right? Can any one of you tell me what are the constraints for this equation to hold good? Yeah, under what conditions or under what constraints does the NPR formula hold good? And under what situations does it fail? Anyone? Yes, what are the constraints, please? So one of the constraints is n has to be more than or equal to r. Correct? That's one constraint. The number of objects that you have should definitely be more than or equal to the number of places in which you need to arrange these objects. That's one. Anything else? And the objects have to be distinct, which means you are looking at permutations without repetition of objects, right? Which means distinct objects, right? That is essentially the reason why I prefer to use the NPR formula, especially for arrangement of people, because with people I know repetition of objects is not possible. That would be absurd, right? I do acknowledge that with alphabets and letters, there can be words with distinct alphabets and repeated alphabets. But there, I think we still have a way of using the factorial concept, right? And that is the reason why I prefer using the NPR formula when it comes to arranging people and arranging alphabets and letters. Why do I not prefer the NPR formula to arrange digits and numbers, right? Is something that may be intriguing some of you, because the NPR formula cannot take care of repetition, right? And cannot take care of zero. So, for example, if I give you these objects, okay, let's exclude the zero for a moment, right? I'll just give you these objects 1, 2, 3, 4, 5, 6, and 7. And I'll ask you, how many ways are there to form four-digit numbers using the objects that I've given you? What would your answer be? Your answer would obviously be 7p4, right? Whatever that may be. Because you're saying, okay, Arvind, you've given me seven objects and you want me to arrange them in four places, so that would be 7p4. And I wouldn't bat an eyelid before saying a yes, right? Because so far, what you've said is right. The 7p4, right, gives you all the possible arrangements of these seven objects in the four places. But the moment you introduce, let's say, a zero, and I ask you to form four-digit numbers, you can't apply the 8p4, because the 8p4 will give you all the possible arrangements of four digits out of the eight objects given. And unfortunately, the formula doesn't know that if you put a zero here, the number will become a three-digit number. The formula doesn't know it. It does its job of giving you a certain number. And then you will have to do your job of subtracting all those numbers that start with a zero. That's a dicey situation to be in, right? Instead, you could go ahead and use the fundamental principles of counting, and it's way easier to solve questions on numbers, right? So that is the fundamental strategy I follow in permutations questions. With people and words and letters, I use the formula as much as I can. I'm not saying I'm not saying I don't use counting methods, right? but I prefer the NPR approach because it's faster. Whereas with counting, with numbers and digits, I take the counting approach, right? Because in the counting approach, I can take care of the constraints well. You've seen questions where questions say, find out how many odd numbers are there. So when such a constraint comes up, you'll obviously have to deal with the constraint first. And that's not possible by applying the formula, correct? That essentially is like my two-pronged strategy, right? Hope that is clear to all of you. Let's take up some questions to see how we can probably apply this strategy to solving questions. Question number 3, right? Fairly simple question, so I'll give you a minute and a half, 90 seconds. Go ahead, give it a try. Okay, we're closing in on 90 seconds. Okay, that's a minute and 30 seconds, and I think that is the time required to solve this. This is a 600 to 700 level question. Okay, and in how many arrangements can a teacher seat 3 girls and 3 boys? Very clear that this is a problem on arrangements, right? So this is a problem on permutations. It is important to identify the keywords, but identifying the keywords should not be the sole strategy in solving a question, right? So there are 6 seats: 1, 2, 3, 4, 5, and 6. This is a part of the visualization process that I was talking of, right? First, second, third, fourth, fifth, and sixth. I want the boys to sit in the first, third, and the fifth seats. So that's a constraint that I have to satisfy, I have to adhere to. So I want a boy here, I want a boy here, and I want a boy here. That's the constraint. And again, remember, this is a part of the visualization. Okay? For a moment now, I want you to forget that there are second, fourth, and sixth seats. Just forget that there are 3 seats. Just assume that there is the first seat, the third seat, and the fifth seat. So there are 3 objects, there are 3 people to be arranged in 3 places. And we know 3p3 is 3 factorial. Now bring back the seats that you forgot, right? Bring the second back, bring the fourth back, bring the sixth back. This would be girl, girl, girl. So arranging 3 girls on 3 seats would again be 3p3, that is 3 factorial. Should you arrange the boys and the girls, or should you arrange the boys or the girls? Clearly, you should arrange both. Both have to be done simultaneously. So 3p3 into 3p3. 3 factorial is 6. Another 3 factorial is 6. So that is 36. So some of you may feel that, okay, I could have done the fundamental principle of counting also. Absolutely no doubt. You would have got the same answer, right? The only drawback in that method, if I can call it a drawback, is that when you are putting numbers, so if you have six blanks, when you are putting numbers, if you end up making a mistake, by mistake, if you write a 2 here, then you might end up getting a wrong answer. That is the only drawback I will see in the fundamental principle of counting method. Whereas application of the formula is direct. You know it is 3 factorial, you know 3 factorial is 6, and 6 into 6 is 36. Right? So let's move on to the next question now. Question number 4. Before we move on to question number 4, I would like to take some questions on alphabets. So if I have the word, let's say, space, I want you people to tell me how many ways or how many words can be formed. Don't start solving yet. How many words can be formed such that the vowels are at the center, or such that a vowel is at the center and consonants are at the corners. How could we solve this? Using the formula, of course. What would the answer be? Yes? Is it a big number? Is it a very small number? Is it a moderately sized number? What is it? What do you think the answer is? So this is similar to arranging people. It's like having 5 people whose names start with S, P, A, C, and E. I want a vowel at the center, right? So I'll put a vowel here. I want a couple of consonants at the corners. So two vowels are there. I have two vowels A and E. So two vowels can be organized in one place in 2p1 ways. These consonants can be placed in 3p2 ways because there are three consonants S, P, and C. Placing three consonants in two places is 3p2. We have taken care of the constraints now. We took care of this constraint. We took care of this constraint. We now have to take care of this constraint. And what is this constraint? There is no constraint on these two seats. There are two people and two places, so that would be 2p2. Right? So 2p1 is 2, 2p2 is 2 again, 3p2 would be 3. 2 multiplied by 2 multiplied by 3 would be 12. What is the point I'm trying to make? The point I'm trying to make is you can solve alphabet based questions, word questions, exactly like how you solve questions where you arrange people, right? Especially if the alphabets are distinct. So next comes the question, what do I do if the alphabets are not distinct? What do I do if I have a word like maybe assassination? How many arrangements can I make of the letters of the word assassination? What is the total permutations I can make? So this clearly follows the model where you have repeated alphabets, right? We count the number of alphabets first: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have a total of 13 objects. So that would be 13 factorial. But out of these 13 objects, do you think all of them are distinct? Had all of them been distinct, there would have been 13 factorial permutations. But there are some distinct objects. There are some identical objects. That's what I meant. So when you have identical objects, you need to divide the total permutations by that number. So 4 factorial Why is the 4 factorial coming in? Because there are, 4 S's. What else is repeating? We have A, we have another A, we have another A. So that is 3 factorial. We have a couple of I's, so that's 2 factorial. We have a couple of N's, so that's 2 factorial. So the point I'm trying to make here is even if you have words and alphabets where there are some alphabets repeating, you can still use the factorial concept, right? So if you know that there are n objects, right, out of which, let's say, p objects are identical, they belong to one category, let's say this category, then you have q objects which are identical again, but they belong to a separate category. It's like S's and A's. S's are identical among themselves. A's are identical among themselves, but S's and A's are different, right? You can also have R objects which are identical, but they belong to the third category. So what will be the number of permutations in that case? The number of permutations would be n factorial by p factorial, q factorial, r factorial. A very, very popular concept. GMAT tests this concept very often, right? Not only directly, you can get direct questions on this, but you can also get application type of questions based on this concept, right? So let's go ahead and solve the second question on permutations. Again, an official question. Go ahead and tell me what do you think is the answer for this. Again, since it's a 600 to 700 level question, I'll give you 1 minute, 30 seconds for this. So Mitra, I think in the last question, 3p2 is 6. Right. My bad. My bad. I think I subconsciously did 3c2. All right. Thanks for correcting my mistake there. Yes. Okay, that's 45 seconds. Okay, that's a minute now. If you guys are done by now, you can probably start posting your answers. All right, that's a minute and 30 seconds. All right, tell me what is the one option you can eliminate straight away here? What is one option that you don't even have to think before eliminating? Yes, please. What is one option you think you can eliminate without even actually having to solve the problem? I would argue that it is E, right? E for echo is the one option that you can eliminate because you know that there are 5 cars, right? Even if these 5 cars were to be distinct, we know that the cars are identical. But even if they were to be distinct, you could have a total of how many possible arrangements? You could have a total of 120 arrangements, correct? And therefore, you know this 125 is sort of a garbage option. It doesn't mean anything, right? So I would eliminate E first. And this is a strategy I follow in a lot of problem solving questions where I look at the options and try to see if there is an option which I can eliminate without having to solve it, right? Knowing the facts. All right. There are 5 parking spaces. and I have 5 cars. Out of the 5 cars, 3 are red, one is blue, one is yellow. Cars are identical except for the color. So it's like having these objects with me, this object with me, and this object with me, right? And it's about permuting these objects in these places and getting different orders. So, for example, you could have a B, R, 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 Y. And this is a part of your visualization. There is nothing wrong in writing down one case and understanding, okay, how does arrangement look, right? You get a much better idea of how to go about solving it, right? So can I have a Y, B, R, R, R? Absolutely, right? Can I have a Y, R, B, R, R? Why not? So now we understand at this stage that we are trying to permute these objects, right? And we have some objects which are identical. How many objects are available in total? 5 factorial divided by 3 factorial, because there are 3 identical objects and there are no other identical objects. These 2 objects are distinct. 5 factorial is 120. You need to remember that. 3 factorial is 6. So that's a part of doing fast calculations. I mentioned a point that many people don't remember the numbers. This is a part I was talking of. 120 by 6 would give me 20. So the correct answer here is A for alpha. The other options can be eliminated. So this, if you observe, in this question, it doesn't look like it is arrangement of alphabets, but that's what it finally boils down. And if you want to boil it down to this situation, you have to visualize the situation, understand that the cars are identical. If you have identical objects, this is probably the concept that the question is testing, right? Arrangement of identical objects, identical alphabets. This is a concept that will really find use in a topic like probability. Questions where you're dealing with complex events. That's one more place where this is applicable. All right. So the next question is a question on numbers. I've already given you the strategy to deal with numbers. So go ahead and solve this. Again, I'll give you 1 minute 30 seconds. So these are some of the easy questions that I've picked. We'll quickly move on to the slightly more difficult ones after this. Okay, I'll give you 1 minute 30 seconds. Riddhi, we'll get there. Just hold on to that question of yours of using the fundamental principle of counting. Just hold on since I've moved to the next question. We'll probably take it up in the Q&A segment when we come there towards the end. Nishchal, I request you to hold on to that question also, right? Okay, that's a minute. Okay, that's a minute and 30 seconds, a little over. I'll probably have to stop the timer here. An integer is said to be diverse if no two of the digits are the same. For example, 327 is diverse, 404 is not. How many diverse two-digit numbers are there? Right? So, diverse two-digit numbers, I want both the digits to be distinct. So instead of giving me that condition explicitly, they're just using different language. But the bottom line is we are looking at numbers where the digits are distinct, and I want a two-digit number, which means I can't put a zero here. A zero cannot be put here. So this place can be filled in 9 ways. For any of you who are finding it difficult to understand, just write down all the numbers, right? You have 10 values, 10 digits, which we use to form numbers. So you can't use a zero here in the first place. You can use all the other 9 numbers. Once you have used a zero, once you have used a number here, right? How many more numbers can we put here? You can put 9 more numbers. If you're getting confused again, I would suggest that you put a number here, let's say put a 7 here, and understand that the 7 cannot be used because you want two of your digits to be distinct, right? So once 7 is gone, you still have 9 digits available. And remember, in the second digit, you can definitely put a 0, right? The restriction of 0 is on the first place, not on the second one. All right. So 9 into 9, there are 81 numbers possible. And this is where the counting methods will help you to solve permutations of numbers and digits faster. You can accommodate the constraints well without any confusion, right? So with that, I complete my first segment on basic permutations questions, right? Where you understood where to apply the formula, where to use the fundamental principle of counting. We now move on to combinations questions. What are the strategies that you need to adopt for combinations questions? What are combinations? Combinations are essentially selections that you can make or groups that you can make, teams, committees, um, um, anything else that I've left out. I think I've covered most of the common keywords that turn up, right? And therefore, whether you're forming a team, you're forming a committee, you're making a selection, order is not important, right? Think of selecting, let's say, a football team. The order in which you select people doesn't define the team that you selected. The order probably defines who is the captain and who is the vice captain. But if you want to select a team, order is not important, right? So, what are the strategies to approach basic combinations questions? I would say that memorize the standard NCR expressions. From my perspective, combinations is a topic which is more of formulas. It's formula oriented, right? NCR would be n factorial by n minus r factorial into r factorial. That's one formula I want you to remember. The second formula is NCR is equal to NC n minus r. Very important formula, right? Third one, NC1 is equal to n. Fourth one, NC0 is equal to 1. Fifth one, NCN is equal to 1. The sixth one is, according to me, the most important because I see that in a lot of questions, coming up in a lot of questions, and I see a lot of people wasting time there. The moment they see NC2, students do n factorial by 2 factorial into n minus 2 factorial. Whereas NC2 is as simple as n into n minus 1 upon 2. You could probably go one step further and say NC3 is equal to n into n minus 1 into n minus 2 by 6. I would even go to the extent of saying you can memorize the first few cases of NC2. I know by memory by now because I've solved so many questions. I know 3C2 is 3. I know 5C2 is 10. I know 6C2 is 15. And I have not tried to memorize it. It has come by way of solving questions, right? So you solve enough questions, these formulas will become memorized. And it's good to know these formula by memory, right? Because it means that you don't have to spend time thinking, okay, what is NCR? This is an important formula, as I said, because it helps you break down bigger combination values into smaller ones. So, for example, 8C6, you don't have to do 8C6. 8C6 is 8C2. And you already have a formula for 8C2. right? So this formula here, this equation helps you break down a bigger expression into some of these smaller expressions. Of course, the second point, visualize the scenario, build cases, applicable here also as in permutations. After you build cases, apply the respective NCR expressions, simplify, and last but not the least, remember order is not important in combinations. Never make the mistake of multiplying by, let's say, a factorial. That would be wrong. You don't do that in combinations. So let's take up a few simple combinations questions now. This is an official question again. I'll give you a minute and 30 seconds on this. Time started. Go ahead. Visualization plays a major part in questions like these because you have an element of geometry coming in this question. A very old official question this is. That probably explains why it looks very different from the ones that we are probably used to seeing on the more recent official guides. Okay, people, that is a minute and 30 seconds. That's time up. You can go ahead and post your answers now. I expect some answers to come up right away. Yes, please. What is the answer for this question? Okay, that would be wrong. Nishal. All right, I see a 864. That's why I said visualizing the situation here is very important. You have, let's say, AB. AB is one of the line segments. CD, how should CD be? CD should be parallel to AB. There are two parallel line segments A and B, AB and CD in a plane. AB contains 12 marked points. Whereas, so there are 12 here. I won't be able to mark all of them, right? 12 points. CD contains 8 mark points. By just showing 5 points, I don't intend to say that there are 5 points. There are 12 points here. There are 8 points here. Now, I'll just ask you a simple question. You have a triangle, let's say ABC. ABC or BCA or CAB. Do you think it represents the same triangle? Or does it represent different triangles? So if I write ABC, triangle ABC, would it be different from triangle BCA? Or do you think it is the same? It's obviously the same. Triangle ABC and triangle BCA are the same triangle. What does that tell you? That tells you that in geometrical figures like a triangle or a square, the order is not important. So if the order is not important, this becomes a question on combinations. And we know that we are used to seeing the factorial concept coming up more on the permutations questions. So I would be very wary of option A and option B because to my trained eye, option A and option B look more like answers given out to a permutation question. Now, how do I form triangles? Right? I need to form triangles by using these points as vertices. How many vertices do I need to form a triangle? I require 3 points or three vertices. In what way can I do it? I can pick two out of these points. So that will be 12C2. I can pick any two, right? Any two. And 12C2 will tell me how many such any 2 points are there. What else can I do? I have to pick 1 point from the other side. So you pick two from here and one from the bottom line, or you pick one from here and two from the line at the bottom. These are the two cases, right? There are no other cases. You cannot think of any other case which will give you a triangle. Clearly, you cannot select the 3 points on the same line. 20C3 is obviously the first answer that I will kind of throw out of the window because 20C3 represents the selection of any 3 points out of 20. And those any three can be these 3 points. And these 3 points can't form a triangle because they're collinear. Now is the time when remembering these values is important. 12C2, right? 12C2 is 12 into 11 by 2, that is 66. Hey, sorry, this is 6 and this is 66. This entire thing is 66. 8C1 is 8. So 66 multiplied by 8. 8 6 are 48. 8 6 are 48 plus 4, 5, 528. Here, this would be 12 into 8 into 7 by 2. So that would be 28 into 12. 28 into 12 is a 336. So 8 plus 6 is 14. 864. The correct answer is D for delta. Right? So at the outset, this seems more like a problem on geometry, but eventually it's a problem on combinations. The moment you understand that order is not important in forming a triangle, right? And if this did not strike you intuitively, you could probably have drawn a triangle, understood that order is not important, and then tried out the combinations values. Why aren't we multiplying them? Pujita, can you do you acknowledge that these are two different situations? Can both the situations happen at the same time? Can you select 2 points from this line and 1 point from this line at the same time? You can't, right? So you either go with this case one, or case two, right? So when it is case one or case two, it obviously has to be addition. Hope that's clear. Pujita? Okay. I'm hoping that it's clear and moving on to the next question. All right. Question number 7 is a rare data sufficiency question on permutations and combinations. Why do I say rare? Because that's what I've seen in my experience that on the GMAT quant section, for some reason, permutations and combinations is a topic that is highly skewed towards problem solving questions. That's probably one reason why it is challenging because in every question you have to go for the exact answer. Whereas in data sufficiency questions like these, there's a certain element that you have to know, which can make your problem solving simple. Go ahead, I'll give you 1 minute, 30 seconds. Yeah, go ahead, solve this. And let's see what the answers are. All right, Pujita, that's good. Always ask yourself, Pujita, when you are in a situation like that, you need to ask yourself, can I do both the things at the same time? Right? Can I perform both the tasks at the same time? If your answer is a no, you obviously add. If your answer is a yes, you multiply. Okay, I see a few D's already coming up. That's interesting. Either of the statements. Right. Okay, that's 1 minute, 30 seconds, 90 seconds. 30 people. Really, is that the way you look at it, Billy? No, I don't think so. Right? If you add 30 people, you can select many, many more pairs of people, my dear friend. A total of 15 different pairs of people can be selected from the people in room A. Now, we don't know how many people are there in room A. So, let's say there are X persons in room A. Yeah? That's an assumption that we can make because that's an unknown. And an unknown gives us a chance of creating a variable. So, what are we trying to find out in this question? We are trying to find the value of X. So, what does the first statement tell us? It says from the people in room A. How many people are there in room A? X people are there. What are we doing? We are selecting a pair of people. Correct? Pair is how many people? We are selecting any two people. So if there are X people in a room and you want to select any two of them, it is XC2. Correct? So XC2 is equal to 15 because the statement says 15 different pairs can be formed. Now, is this sufficient data for us to find out X? Can we find out X from here? The answer is a definite and a resounding yes. You know why? Because every NCR value, right, is going to give you one number, right? If you look at 5C2, 5C2 is a 10. What is 4C2? 4C2 is a 6. What is 6C2? 6C2 is a 15. What is 7C2? 7C2 is a 21. Every NCR value is mapped to a unique number. There is a 1 is to 1 correspondence. And therefore, in a problem like this, if you know that XC2 is 15, you can be sure that X is a unique value. And in a DS question, we don't have to find the value of X, right? So therefore, in an exam, if you come across this question, the moment you see XC2, I want you to say, I can find out X, so the first statement alone is sufficient. Second statement, if there were one fewer persons in room A, so instead of X, had there been X minus 1, a total of 10 different pairs of people could be selected. So how many pairs can I select now? I can select 10. Again, for this particular equation, right, there's only one and one possible value of x minus 1. So x minus 1 is unique. If x minus 1 is unique, x will also be unique. And if x is unique, we have answered the question. The correct answer here is D for delta. So the message from this question is, if you have an equation involving a combination where there's an unknown, right? Never think that this will be possible, this will be satisfied by multiple values. It will always be satisfied by one value, right? And I don't know how many of you have realized this by now, In GMAT DS questions, if the first statement turns out to be sufficient, you get the answer as 6. If the second statement turns out to be sufficient, you'll again get the answer as 6. And here, you will get the answer as 6 because 6 minus 1 is 5 and we know 5C2 is 10. That is one more advantage of knowing the values, right? Knowing the combination values. The moment you see a value, it'll strike you that you've seen this number somewhere. It'll probably put you on the right path towards the answer. Any questions till now? So, using these questions, I hope I've given you an idea of how we recommend going about such easy and medium level combinations questions, right? Where there are not too many complications involved. With that, I move on to the penultimate section of the day, permutations and combinations questions with restrictions or constraints. These are the slightly tougher questions. They're also tricky because they have constraints which can be positive or negative or both. So, what kind of questions come up in this segment? You may have seen questions that look like this, right? What is the number of ways in which two men, you can make a committee where two men are not together? What is the total number of handshakes that can be made so that the people within a group don't shake hands within themselves? What is the number of ways in which you can select a committee with at least one woman, right? So you can see that in these cases, right, the common philosophy that we are following is that if we want something to happen and we know that this is a difficult thing for us to deal with, we find out the total number of cases first. Because finding out the total is always the easiest thing that you can do because total is like unconditional. It's like unconditional love. You don't have to apply any constraint on finding the total, right? Additionally, when you find out the total, it will help you eliminate certain answer options which are either bigger than the total or equal to the total, right? That's one more advantage of finding the total. From the total, you remove the cases that you don't want. So this is what you want and this is what you don't want. But you know that finding out what you want is a complicated task. You don't want to go that way. And you also acknowledge that finding out what you don't want is easy actually. So we follow this approach of finding the total and then subtracting these cases to end up with what we want, right? So these are the typical questions that come in permutations and combinations with constraints. And this is the philosophy that you have to follow in all such questions, right? Another type of constraint that can come up on questions involving numbers can be numbers should be divisible by 5, or let's say numbers should be even, or numbers should be odd, wherein you deal with certain specific digits. You can have questions where uh, the question can say numbers should be divisible by 4, but that's very, very, very rare on an exam like the GMAT, right? This is one more type of constraint, specifically in questions on numbers and digits, right? With this, let's see if we can solve a few questions now. So this is an official question again, but this is a slightly difficult question now, a 700 level question. So I'll give you 2 minutes on this. Go ahead, solve this, and let me know what your answers are. And I want all of you to really eliminate a lot of answer options here actively, right? Rather than just trying to solve the question. I also want you to use to be smart and eliminate answer options. Okay, that is 1 minute. That's a minute and 30 seconds. You have 30 seconds more. All right. We have an answer. We have our first answer. All right, people. That's 2 minutes, and I see a couple of ways. Any other answers, people? Please go ahead. Don't sit on the fence. Type your best answer. All right. So this is a question where you'll have to deal with constraints first. What is a constraint? The constraint, there are multiple constraints here. I want my numbers to be three-digit positive integers. So I'm looking at numbers from 100 to 999, right? Am I looking at all of them? I am not. I am looking at numbers which are greater than 700. So what does this boil down to now? I am looking at numbers from 701 to 999. Now, am I looking at all numbers from 701 to 999? No, I'm not. I want all numbers where the three digits are all different. So I don't even want a number like 999, right? I don't want a number like 727. 727 is not allowed, right? 737 is not allowed. I don't want a number like 883, right? This is a part of my visualization, right? Where I understand what I want and what I don't want. What numbers do I want? I want a number like 725, right? 725 is allowed? Absolutely. Is 735 allowed? Absolutely. Is 749 allowed? Yes. Right? This is a part of my visualization. How many are odd integers? So by now you're wondering, why is Arvind talking only about 725, 735, 749? Because I'm looking at odd integers. What makes a number an odd integer? What is that one element in a number that makes an integer an odd integer? It is the unit digit, right? You decide whether a number is odd or even based on the unit digit being odd or even, right? That is the constraint that you have to take care of. But can you directly go about taking care of that constraint? You can't, right? You need to understand that you have to break down this problem into three cases. First case, number starting with 7. Second case, number starting with 8. Third case, number starting with 9. And because we have three cases, can we say it is an OR? I think we can. It's like saying my number can start with 7, or my number can start with 8, or my number can start with 9. Right? Great. Now, here, when we are framing the numbers, when we are forming the numbers, we are used to going from left to right. That's the habit. We have got habituated to that. That's something we need to not do on this question, because we need to deal with the unit digit first. So, in how many ways can I fill the unit digit here? How many objects can I fill in the units place? Anyone? What all can I fill in the last place, in the last digit? Okay, for the benefit of all of you, I'll just write down all the digits here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 10 digits. How many digits can I populate the last digit with? Clearly, if I want odd numbers, I can't use a 0, I can't use a 2, 4, 6, 8. These are gone. How many are left? 5 are left. Can I write 5 here? Obviously not. Why? Because I've already used up 7 and I want all the 3 digits to be different, right? So this place can be filled up in 4 ways. Okay, let us say I fill this place with 3. Can I use the 3 here? I can't, because I have to form a number where 3 digits are all different, right? So I've used up a 7, I've used up a 3. How many ways are there to fill this place? If you said 8, right, that is where you're wrong, because there is one more condition that we have not taken, that is non-zero, which means I cannot take 0. So out of the 10 objects, 0 is out. I only have 9 objects. Out of 9 objects, I've already used up 2 of them. So 7 into 4, there are 28 numbers, right, between 700 and 800, which are odd numbers, and all 3 digits are different, and all 3 digits are non-zero. If this works like this, do you think this also works the same way? I think so. The only difference is here we could not use a 7, there we could not, here we cannot use a 9. So this also, so we have 28 numbers again, right? Which start with a 9, have 3 different digits and 3 different non-zero digits. But here is when you have to be careful. In the last place, you can use all the 5 because the first digit is not 7 or 9. You can use all the 5. Here, you can still only use 7. So 7 into 5 is 35 numbers. And because we have a OR, what do we do finally? We add the numbers. 28 plus 28, 56. 56 plus 35 is 91. So when you have constraints, people, you'll have to deal with the constraints first, right? And then take care of the places where there are no constraints. You can do whatever you want with them. But on places like this, you can't do whatever you want. You'll have to adhere to the conditions given, right? So the answer here is 91. Hope all of you like this question. Let's move on to question number 9. Question number 9 is a question on combinations. So I'll give you 1 minute and 30 seconds because I feel that combinations questions are inherently easier compared to permutations. Numbers are smaller. So I'll give you 1 minute 30 seconds. The level of the previous question was a 700 level question. The previous one was a 700 level. I have no doubt about it. Okay, people, that's a minute and 30 seconds, a little over. Please post your answers now, please. Okay. Billy, you telling, you're asking, what is it like? All right. A committee of 3 people is to be chosen from 4 married couples. So you have 4 married couples, right? You can say H1W1, H2W2, H3W3, H4W4. So how many people do we have in total? We have 8 persons. What do we have to do out of these 8 persons? We'll have to select a committee of 3 persons. So what are the total number of committees we can form? The total number of committees we can form would be 8. There are 8 persons out of which I need to select any 3, right? There is no condition. Why is there no condition? Because we are trying to find the total number of committees. So what is 8C3? 8C3 would be 8 into 7 into 6 by 3 into 2 into 1. 3 twos are 6. So I know that I can form a total of 56 committees. Unfortunately, in this question, I don't have an option which is more than 56. Otherwise, I would have taught you how to eliminate that answer option. If you have a number more than 56, you know that that is not your answer because you've still not applied the constraint. You've just found out the total committees, right? What do we have to do now? What is the number of different committees that can be chosen if 2 people who are married to each other cannot both serve on the committee? Okay, which means I want to find out the committees with no couple. If I want to find out the number of committees with no couple, what should I do? From the total number of committees, I have to subtract the committees with how many couples? I can only have one couple, right? With a couple. Now, how many committees are there with the couple? Committees with one couple. By the way, let me remind you that my committee is of 3 people, right? Now I know that my committee will have one couple. Which one? I don't know. I know there are 4 couples. So 4C1, right? I can select any one out of the 4 couples. By doing this, how many people would I have filled? I would have filled 2 places. How many more places are remain to be filled? 1 place. So I have to select one more person out of how many? Right? There are 6 more people. Why are there 6 more people? Because I've already selected 2 people out of 8. So this is the selection of the couples. This is the selection of that one more person from the remaining set of 6 people. So this is 4 into 6, that is 24. So this is 56. This is 24. 56 minus 24 will give me 32. The correct answer option here is E for echo. We are not filling the spaces here, Pujita. I have just gave you an example so that you don't get confused. I said we have to select 3 people, and selecting 3 people means selecting one couple. So 2 people selected and one more single person selected. I did not intend to say that we are filling places, right? I'm sorry if I confused you by putting the blanks there, but I hope you understood it now. So when there are constraints, especially when there are negative constraints, what do you mean by negative constraints? You see here, negative constraints like 2 people cannot serve on the committee, or 2 people cannot be together, or these 2 people don't want to sit together. Negative constraints. Find the total, subtract the cases that you don't want, and you'll automatically get whatever you want to get, right? A very important strategy. And I've seen questions coming up umpteen number of times where this strategy is, expected to be applied by, GMAT expects you to apply this property, right? So finally, let's look at one or two PNC questions, application level questions, where you not only need to know PNC concepts, but you also need to know some other concepts as well, right? So this is a question on numbers, divisibility concepts being tested here. PNC concepts are also being tested in a very, very subtle way, right? Go ahead. I'll give you 2 minutes on this. Pujita, there is no alternative method for the previous one, right? The other alternative method could be to develop cases, right? Where you'll have to take, let's say, for the first slot, husband one. For the second slot, what could be done? For the third slot, what could be done, right? That's a very cumbersome process, and that is why you should not go that way. So this is like the backdoor approach, right? You're finding the total and you're removing whatever you don't want. So especially when you have negative constraints, never try to develop cases because there'll be a lot of cases, and even if you miss out one case, you're in trouble. Okay, 1 minute up. That's a minute and 30 seconds. Okay, people, that is 2 minutes. Okay, the difference 942 minus 249. So for example, 942 minus 249. 12 minus 9 is 3, 13 minus 4 is 9, and 8 minus 2 is 6. So when you divide 693 by 7, 7 nines are 63, 63 again, 7 nines are 63. So you see that 693 is perfectly divisible by 7. So this is just an example given. The example is given here to let you know that you are taking a number and its reverse. 942 is the reverse of 249 or the other way around, right? If A, B, and C are non-zero digits, how many three-digit numbers A, B, C are possible such that the difference A, B, C minus C, B, A is a positive multiple of 7, right? Now, looking at this example, if you end up falling for the trap of trying values, then I would say that you'll find it, mighty hard time in getting to the answer. ABC is a three-digit number. It can be written as 100A plus 10B plus C. Because remember, this is the units place, this is the tens place, and this is the hundreds place. The place value of the hundreds place is 100. So you'll always multiply 100 with A to get the place value of this number. The place value of this number will be 10B. And the place value of C will be C itself because it's a units place. So similarly, CBA would be 100C plus 10B plus A. What are we doing? We are subtracting the second equation from the first. So ABC minus CBA would give me 100A minus A would give me 99A. 10B minus 10B would get cancelled. C minus 100C would give me 99C. So what do I know? I know ABC minus CBA, right, is 99 times of A minus C. What do I want? I want my difference to be a positive multiple of 7. Now I know that this difference should be divisible by 7, and when I divide it by 7, I should get an integer. Now clearly this part is not divisible by 7. 99 is not divisible by 7. Therefore, the only way in which this number can become divisible by 7 is if A minus C becomes divisible by 7. But we know that A, B, C are what kind of numbers? A, B, C are single digit values. They are digits. So how do I make it divisible by 7? I can take A as 9, C as 1. C as 2 rather. I can take A as 8, C as 1. Can I take 7? Can I take 7 and 0? I can't take 7 and 0 because they are non-zero digits. People who miss out this non-zero will end up falling for the trap answer. There is a trap answer here, right? So I know my number is either starting with 9 and ending with 2, or what is or? Addition. Starting with 8, ending with 1. Are there any constraints on the middle digit? I don't think so, except that the digit should be non-zero. So how many ways can I fill this up? 9. How many ways can I fill this up? 9. 9 plus 9 is 18. People who miss out on this word non-zero will end up getting D for delta, which is the trap answer. So although this seemed a slightly difficult question, right? It is not. It is not, especially if you can break this equation down and develop cases. Developing cases is very, very, very important. Never shy away from developing cases, especially if you know that there will be either 2 or 3 cases, right? So with that, I'd like to summarize our discussion here by saying that if you want to do well in PNC, the first thing you need to start off with is you need to, um, you know, internalize the fact that a lot of problems in PNC, as you saw, don't even require us to apply formulas. Just the previous problem, I didn't apply any formula. I just used the counting principle. A lot of times, fundamental principle of counting is very, very useful instead of using formulas. Right? If you are using formulas, use formulas in the situations that we discussed. NPR formula to solve questions on people, arranging people and arranging alphabets and words, whereas fundamental principle of counting for arrangement of numbers and digits. When it comes to combinations, you might want to remember NCR, NC1, NC2, right? Some of these commonly tested expressions, because combinations is more of a formula oriented topic. But very importantly, you need to learn how to visualize the scenario defined in the question. That is what will give you the cases. If you don't visualize the scenario, you don't know what the cases are. You don't know what the cases are. You don't know what the numbers are. This is something that I've seen in official questions. Whenever there's a or, right? Task A can be done by A or B. That's a clear indication that you have to use the or. Either A can do this or B can do that. So there are two cases. So the indirect hidden clue there is you have to form two cases, right? The moment you form two cases, you can deal with one case and multiply it by 2. The last thing, if you are dealing with negative constraints, questions with negative constraints, you can use the backdoor approach or the backward solving approach, right? Which is finding out the total. Remember, as we discussed, finding out the total will help us eliminate some answer options also. From the total, we just remove what we don't want. This will automatically give us what we want. So at this stage, I'll just post the last question for the day. I call this the challenger question because, right, um, in some ways we have done a lot of workout. This has been like leg day for some of you, and I'm asking you to do the last set of repetitions, and you're like, no, I can't do it. That's why I call this the challenger question. Go ahead. I'll give you 1 minute 30 seconds for this, and give me an answer in 90 seconds, people. Yes, you're really you're welcome, Gautam and Ayushi. Sorry, you're most welcome. It's my pleasure. Okay, 1 more minute for all of you. 30 seconds more. You guys can post your answers if you think you're done. So this is an interesting question, very nice question that I found on GMAT Club itself. So GMAT Club is a place where you can find some of these brilliant questions, um, aptly named. Right, GMAT Club is the place for you to be if you want to score well on the GMAT. Wonderful question. Okay, that's time. So, how many different 5% teams can be formed from a group of X individuals? So, you know that there are X persons available. So, your pool, you have a pool of X persons, and you want your team should have 5 persons. So, how many teams can you form? You can form a total of XC5 teams. What does X depend on here? XC5 depends on X, right? XC5 depends on X. The question is, what is the value of X? Statement 1 alone. If there had been X plus 2 individuals in the group, had there been X plus 2 individuals in the pool, exactly how many teams could be formed? 126 teams could be formed. What type of teams are these? How many person teams? 5% teams. So you're saying out of X plus 2 people, if I select 5 persons, I'll get 126 teams. Can I find out X from this? I think we can. We solved a similar problem. We said if we have a combination defined uniquely, we can find a unique value of the X of the variable. Remember, we discussed every combination is mapped to a unique value. Second statement alone, if there had been X plus 1 individuals in the group, exactly 56 different 3% teams could have been formed. So X plus 1, C3 would be 56. Again, can we find out X from here? Absolutely. X would be unique. So second statement alone is sufficient. Because each of them are sufficient, the correct answer here would be D for delta. So at this point in time, people, I think time for me to call it a day in terms of posting and solving questions. I hope you have found a lot of the questions useful. I hope you've uh, I hope you'll be taking a lot of messages back with you today from this session. And I hope that it will end up helping you in becoming a better problem solver when it comes to permutations and combinations questions, hopefully. So, from our perspective, we would like to give out this value add to all of you, right? Um, we'll be posting some links in the chat box, so you can use the link. You can click on the link, and you can use this coupon code to avail a flat 50% off on our GMAT comprehensive course, the Crack Verbals GMAT online course, right? You can click the link in the chat box. So at this stage, if any of you have questions, I'm open for it. I'm all for it. Go ahead, post your questions in the chat box, and I'll be happy to answer. All right, people, thank you very much. For those of you who are signing off at this time, thank you very much for joining this session and being so interactive over the last 1.5 hours or so. I think I've exceeded my time by almost like 40 minutes or almost an hour. But I hope it was like worthwhile, right? Yes, please, Nishchal, Riddhi, you can go ahead with the questions, please. See, Riddhi, the problem with having identical objects and using fundamental principles of counting is that it will leave you confused, right? Because the objects are identical. For example, in that problem, the R's were identical. So when you start applying the fundamental principles of counting, you will ask yourself, in the first place, how many objects can I fill, right? And you'll be confused whether it is 5 or 4. And eventually you will say, okay, it is 5, then 4, then 3, right? But you will realize that 5 into 4 into 3 is not possible because it will contain duplicates. Then you will divide. So instead of that, if you have repeated objects, I would still recommend the factorial approach. There has to be a reason why that method is being proposed, right? I don't think I've seen anyone solving that kind of a problem using the fundamental principle of counting. This still question 9. I know it's the wrong approach, but why C 8C1, 6C1, 4C1? All right. All right. Let me go back to the ninth question now, right? Hmm. You're welcome. 8C1 into 6C1 into 4C1. Yeah, Nishal, what exactly is it now? Are you asking me why 8C1 into 6C1 into 4C1? Yes, Nishal. So what you're essentially saying is you will select one person out of 8, followed by um, one person out of 6, and one person out of 4. The problem with that is, who are those six people that you're talking of? The problem is the formula doesn't know who we are picking, right? So, for example, if you say 8C1, which one are you picking? 8C1 could be any one of these eight people, right? So, if one of them, if you pick, let's say H1, right, you are removing W1, and that's why you're saying 6C1. Whereas one more reason why you can't do it is the activity defined is different. You have to select a total of three people and not one at a time, right? Yeah, but HC1, how do you know which person was selected? That's the point I'm making. And because you don't know which one was selected, how do you know which one to leave out? Whereas in the 4C1 into 6C1 approach, you know that out of four couples, you have already selected one. And you don't have to worry about them because you've selected both. Getting the point? Again, you're hypothesizing now. You're saying, let's say it was H1. You again come to the same case of 6C1. 6C1 is again the same situation, right? You don't know who is being selected. Why do you want to go that way? Correct. Again, 6C1, you come to the same situation again. You don't know who is being selected. And if you say, let us say H2 got selected, there will be somebody else who will argue why not H3 got selected. And then what cases will you deal with? You'll get just entangled in a web. Yeah. Any other questions, people? Nishtal, I hope that answers your question. Yeah, you're welcome. Yes, people, any other questions, please go ahead, post your Post your questions in the chat box. I'm all here for at least another 5 minutes before we wrap up this session. Thanks, Nishchal. Thank you. All right, people. Thank you very much. In case there are no other questions, it's time for me to finally call it a day today. It has been my absolute pleasure doing this webinar on behalf of Crack Verbal for all of you, and I hope by doing this, I've given you an idea of what kind of content we bring to the equation in terms of helping GMAT test takers get to their target score. As a company, we've always believed in recommending official questions to all students because we feel that is the only resort that is there to do well on the GMAT, right? Considering that's the core philosophy that we follow, that should give you an idea of what kind of questions we use in our sessions, what kind of questions you can find on our course, and how that can immensely benefit all of you, right? So please go ahead and log on to some of our social media channels. We are present on Facebook, YouTube, Instagram, and LinkedIn. The links have always already been posted in the chat box. You can click on those links and um, have a look at our social media channels. And yes, till I see you all on the next webinar. Hopefully, I wish you all the best with your preparation for the GMAT. Wish all of you a good time ahead. Stay safe. Take care. And I hope to see you on another webinar on a quant topic here on the YouTube live channel of GMAT Club. Right? Thank you very much.